Good evening, madam. My name is Odongo Emmanuel, a student of Makerere University, College of Computing and Information Sciences, Department of Computer Science. I'm pursuing a Bachelor of Science in Computer Science. My registration number is 23-U-1595. I am a Year 1, Semester 1 student. Madam, in my presentation, I am going to present about the history of the development of computers from the first generation up to the latest development. Then from there, I am going to take you through the evolution of the x86, Intel, and the ARM architecture. To begin with, madam, the history of computers, we often refer to the advancements of modern computers as the generation of computers. Looking at the first generation, it is from the year 1940 to 1955. Here, machine language was developed. It is the one which was used in this, and the technology here was vacuum tubes. Vacuum tubes were used for circuitry. For the purpose of the memory, they used magnetic drums. The machines were complicated, large, and expensive. They were most reliant on batch operating systems and punch cards. As output and inputs, magnetic tapes and paper tapes were implemented. For example, the UNIAC, the UNIVAC 1, and so on and so forth. We go to the second generation. The second generation here, the technology was the transistors. This was from the year 1957 to 1963. That was the second generation. And here, COBOL and the Fortran were employed as the assembly languages and the programming languages. Here they advanced from vacuum tubes to transistors. They made the computer smaller, faster, and more energy efficient. And they advanced from binary to assembly languages. For instance, the IBM 1620, IBM 7090, the CDC 1604, and so on and so forth. The third generation here was the integrated circuits. The hallmark of this period, 1964 to 1971, was the development of the integrated circuits. A single integrated circuit is made up of many transistors, which increases the power of a computer while simultaneously lowering its costs. These computers were characterized by being smaller, more reliable, and less expensive than the predecessors. And in this generation, high-level programming languages like Fortran 2 to 4, COBOL, Pascal were utilized. For example, the IBM 360 series, the Honeywell 6000 series, the IBM 360/168, and so on and so forth. They moved to the first generation. Now, the first generation, the technology all here was based on the microprocessors. The invention of the microprocessors brought along the fourth generation of computers. And this was the year 1971 to 1980. And here they used C, C++, and Java. Those were the programming languages used in this generation. And in this generation, for example, the Star 1000, the PDP 2, the Cray 1, the Cray XMP, and the Apple II. And in this generation, this is when they started producing computers for home use. They moved to the fifth generation, and in the fifth generation, it was much of artificial intelligence, and that was in the year 1980. And they continued in advancing in the technology up to date. The use of parallel processing and superconductors are making this a reality in this generation, which provide a lot of scope for the future. The fifth generation computers use the ULSI, that is the ultra large scale integration technology. These are the most recent and sophisticated computers. They also use Java, C++, .NET, and more other programming languages. Example of computers here, we have the IBM, the Pentium, the desktop, the laptops, the notebook, the ultrabooks, and so on and so forth. Now, when we look at these generations, basing in terms of centuries, we look at the different inventors who tirelessly tried to bring the computer into the world. They had realized that they were creating more than just a number cruncher or more than just a calculator. They had to address all the difficulties associated with inventing such a machine, implementing the design, the actual building of the stuff itself, the machines. And this history was arranged and the years kept on developing. For example, we look at the venture like the Charles Babbage in 1822. This man was a mathematician, invented the steam-powered calculating machine, capable of calculating numbers, and so on and so forth. That was in the 19th century. We move on to the 20th century. That was from around 1930, where we see different developments arising in different years. And this is where you see the hallmark. As I was presenting in the generations, I categorized it in a given time range, and this is now splitting it in terms of different years, what the development was in different years as technology kept on moving on, and which languages they were using, what different inventors came up with, and so on and so forth. Example, in 1964, Douglas and Gilbert proposes a modern computer prototype that combines a mouse and a graphical user, that is the GUI, the graphical user. There you will see the issue of plug and play. Yes. Technology kept on moving on in a number of years. But my point of interest here, I want to take you to the latest century, that is the 21st century, where we are in up to date, and the technology which was there. This is the 21st century, whereby you see the introduction of the USB flash in 2000, the introduction of Facebook in 2004, and so on and so forth. My point of interest is to see the latest development where they ended, and that was in the year 2017. The Defense Advanced Research Project Agency, that is the DARPA, is developing a new technology, that is the molecular informatics program that uses molecules as computers. Chemistry offers a rich set of properties that we may be able to harness for rapid scalable information storage and processing. The investor like Ann Fisher, program manager in DARPA's Defense Science Office, said in a statement that millions of molecules exist, and each molecule has a unique three-dimensional atomic structure, as well as variables such as shape, size, even colors. The richness provides a vast design space for the exploring novels and in multiple ways to encode and process data beyond the zeros and the ones of current logic-based digital architecture. That is where the technology is moving to. That is after the world's first programming quantum computers were built in 2016. After Apple introducing the watch, the Windows 10 was released by Microsoft. So that is in brief the history and the development of computers. Well, looking at the Intel evolution of Intel x86 and the ARM architecture. is evolution of Intel x86 and ARM architecture. Intel x86 architecture has evolved over years from a 29,000 transistor microprocessor 8086 that was the first introduced to a quad-core Intel Core 2, which contains 820 million transistors. The organization and technology have changed drastically. Some of the highlights of the evolution of architecture are the ones I am going to explain below. Looking at the 8080 architecture, it was the world's first generation purpose microprocessor. It was an 8-bit machine with an 8-bit data path to memory. It was used in the first personal computers. Then you move to the 8086 architecture. It was a 16-bit machine and was far more powerful than the previous one. Then you move to the 8286. It has an addressable memory of 16 MB instead of just 1 MB and contains two modes, real mode and first generation 16-bit protected mode. It has a data transfer width of 16 bits and a programming model of 16 bits. That was the 8286. Then the 8386, it was the Intel's first 32-bit machine. Due to the 32-bit architecture, it was able to compete against the complexity and the power of microcomputers and mainframes introduced just a few years earlier. Then we see the 8486. It introduced the concept of the cache technology and instruction pipelining. It contains a write protect feature and offered a built-in mass coprocessor that offloaded complex mass operations from the main CPU. From there, we now see the Pentium. The use of superscalar techniques was introduced as multiple instructions started execution in parallel. The page size extension, that is the PSE feature, was added as a minor enhancement in paging. Pentium Pro came in after Pentium. Then there went to Pentium 2. It was able to process videos. That one could handle even graphics. Then there went to Pentium 3. Pentium 3 contains the streaming extensions, the instructions, and supports 3D graphic software. That is Pentium 3. Then you go to Pentium 4. It implements third generations. Then you go to the core. That is core 1, then the core 2. That is the latest. Now, when you look at the advantages of the x86 architecture, there is things like complex compatibility, the performance improvement, the kind of things to do with the versatility, broad industry support. Those are the advantages. Now, when you look at the disadvantages, it talks of the complex instruction set. The x86 architecture has a complex instruction set, which makes it difficult to optimize code for performance. Then power consumption, it consumes a lot of power. It has led to a significant increase in power consumption. You get it? Then there is heat dissipation. It has led to the development of more sophisticated cooling systems. That is the introduction. Then the costs, it is getting more expensive here and there. That is the end of my presentation, and this is the reference book for my presentation. It is called the life story of a technology by Sweden. That is where I refer you to in case of any other details. I thank you so much for listening to me, and thank you for actually sparing your time to listen to my presentation. I remain Odongo Emmanuel, a student of courses. Thank you so much, madam.